Hey guys, what's up people? Hello, yes, I can see that punctuality. Guys, there was a lot of technical issues there, that's why I could not join a little sooner. So I'm in the office, so that is why all of these issues. Welcome back, how you all doing? Hi Devapita, can you guys all see me and hear me? Everyone, hi Muskan. My day is going really bad. I had a lot of technical issues. I could not join the session on time. Hi Selina, what's up? Welcome. And this is like a new scenario. I'm not used to this. So yeah. Hello people, welcome to the session. Yes, I can't see any of you guys. I mean, I'm not able to read the chat properly, but anyways, hi and welcome to the session people. I hope that all of you guys are doing good. So without wasting any more of your time, let's begin because yes, there's not much time left. I have another session after this as well, so let's do it. So yeah people, this is going to be the second session of calorimetry. Today we'll be talking about heat capacity and specific heat capacity as well. So welcome to the session. My name is Anoop. So let's begin. All right. How do you move to the next slide? There's another. Yes. So this is heat capacity and specific heat capacity. So this is the quote for today. Positive thinking invokes more energy, more initiative, and more happiness. Yeah, people. But yes, you should also, from my experience, you should also try a little. And that's what I felt today because I was all set up and everything was ready. But then last minute I understood that, nothing is going to work. So I had to change everything and then quickly join back. Anyways, so positive energy is the thing. Alright people, moving on. Alright, yes, anyways. So in the last session guys, if you remember, we talked about heat and temperature. So we have Abhishek sir over here as well. And today we'll be talking about heat capacity and specific heat capacity. That is what we're going to talk about. Yada, I'm in the office today. Apparently I am. So let's begin people. So this was the homework for the last question. By the way, measurement of quantity of heat is called as what? And the answer to that question, voila, is nothing but calorimetry. That is the answer. I know, right? Exactly. So that is the answer, people. Measurement of quantity of heat is what is called as calorimetry, and that is what we studied in the previous session. If you haven't watched that already, so make sure that you do that as well. So people, we have a quiz time apparently, but then I have not opened the Mentimeter. I am still trying to figure it out. Just give me 1 second. I'll just open the Mentimeter as well. Give me 1 second, guys. Give me 1 second. Let me open up the Mentimeter. I have no idea if I can open it right now or what. Give me 1 second, people. So we have a couple of questions that can be asked as Menti. Okay. It's so hard to deal with this thing. It's like, wait, no. Wait, what? Which one is it? Okay. Guys, give me 1 second. I'm trying to figure this out. Give me 1 second. Give me 1 second. Give me 1 second, people. Yep. So we have a Mentimeter for you guys now, but then again, like I told you, I'm very new to this, people. This is probably my first session with the smart board, so I'm still trying to figure this out. So the code for today is this, people, 7768346. That is the code for today. So quickly join the Mentimeter and then we'll start. I know it's kind of awkward because yeah, people, I am really not sure with this. This is the first time I'm using a smart board, so I'm not really sure. So quickly join. Once you're in, just let me know so that we can begin with the topic for today. Let's begin. All right. Anyways, the code is the 7768346. Yeah, lateral inversion. Yes, this is the code for today. Once you're in, let me know, people, so we can begin today's session. Yeah. All right. So couple of you guys are here, 9, 10. Okay, where's the rest of the gang, people? I don't even know how many of you guys are here in the session. So yeah, I'm guessing it's only so much. So I'm going to begin the topic for today then. We're going to start with the Mentimeter. So I have about 5 questions from the previous session. Okay, this is already question number 4. Wait, which is this question? Wait, what? 1 second, guys. 1 second. This is so hard. I'm not. Okay, wait. Wait, what? Give me 1 second, people. Give me 1 second. Alright. Hey, worked. Wait, what? Okay, wait. Finally. 1 second. Yes. We're supposed to start from here. Yes. You know how much of a noob I am in this now. Alright, so first question, people, on your screens right now. Let's go. Start. Let's go. First question. This is super hard. Okay. Alright people, this is the question. When hot body is in contact with a cold body, internal energy of the cold body, options: decreases, increases, remains the same, or either increases or decreases. Yeah. Let's go guys, let's go. What do you think is the right answer? When hot body is in contact with a cold body, the internal energy of the cold body increases, decreases, remain the same, or increases or decreases. Yeah, let's go. 2 more seconds and we are done. Let's go. That is the answer for this question. The answer for this question is, guys, obviously it's going to increase, right? Because heat flows from hot objects to cold objects. So when you have, two objects in contact and one of them is cold and the other is hot, the internal energy in the second one, the cold object will start to increase. That's why it'll start to become hot, right? So that is the answer for the first question. It's okay to get it wrong, but yeah, people, don't ever forget that. That will be the answer for the first question. Moving on to the leaderboard. Here it is. Mohit G on the top, followed by Joseph, followed by Lola, followed by Earthman, Bell, Abhishek sir. Day. Too much dialysis. Ignore this name. And it's X line B. Hello and Tweeto. Congratulations. Well done, people. Well done. Moving on to the second question. Abhishek sir is right here, by the way. He's standing outside. He's giving me death stare and all. Alright, second question. I'm going to start right now, people. 3, 2, 1. Moving on to the second question. Here's another one from the previous question again, from the previous session. Yes. Hey guys, this is going to be it'll take some time for me to get used to it. This is the first time I'm using a smart board, so it'll take some time. 1 calorie is equal to how many joules? 1.2 joules, 120 joules, 4.2 or 4,200 joules. 20 seconds. Let's go. Yo. It's okay. Now you guys can see what is my real size also, by the way. Yeah, this is what I look like right now, by the way. For all those who are still wondering, I am like a mini elephant right now. So yeah, I told you this. You did not believe me, no? Now you believe me. 18 of you are not bad at all. And yes, definitely yes, it's 4.2 joules. It's around 4.186, somewhere around that. So you can round it off to 4.2 itself. Well done, people. Well done. That is the answer for the second question. Here's the leaderboard once again for the second question. The leaderboard is so forth. We have Mohit still on the top, followed by Joseph, followed by Bhargavi, Dev, Anoop sir, high five to you, Abhishek sir, Iror, hello, KJ, Ayushi, Tushar, and Aditi as well. Congratulations. Well done. Moving on to the next question. Here's another one for you people. The third question for the day. Let's go. If you don't work, that's all. I'm going to start punching this board right now. Third question. Let's go. Which of the following factors affect the quantity of heat absorbed to increase the temperature of a body? Which of the following factors affect the quantity of heat absorbed to increase the temperature of the body? Options: mass of the body, increase the temperature of the body, material of the body, or all of the above. Which of these do you think are the factors that affects the quantity of heat absorbed to increase the temperature of the body? Let's go, people. Yes, Kirti ji, what's up? Welcome back once again, guys. I'm sorry for being late. There was a lot of technical issues, that's why. Anyways, here it is. 19 of you guys got the right answer. One more than the other one. Exact. The previous question, absolutely correct, people. Yes, once again, the mass of the body is something that is dependent on. The temperature of the body also matters. Like I told you in the last session, for example, if you talk about water itself, it's much more easier for you to increase the temperature of water when it's at low temperature. But it is much more difficult for you to increase the temperature when it's at low temperature. But it's much more easier for you to increase the water when it's at already higher temperature. Like for example, if it's already at 95 degrees Celsius, if you want to increase it to 96, it's much more easier rather than increasing from 3 degrees Celsius to 4 degrees Celsius, because here in 3 degrees Celsius to 4 degrees Celsius, you have to supply more heat energy. That's why. All right, good one, people. Here is your leaderboard at the end of the third question as well. Move. Here it is. Mohit ji still on the top, the puffer fish, followed by Joseph, Bhargavi, Dai, and hello, KJ, Tushar, Aditi, and Wolfmeister as well. Congratulations, people. Mohit was the first to answer as well. I think that is pretty much it for the first quiz time. I'm not really sure. Let me just check that. Once again, people, let me go to the next question. Okay, yeah, that's it for the first question, people. Let's now move on to the topic that we have at hand. It's not going to take much time, just a couple of minutes is what it is going to take for me to move on to the topic. So we have only 2 topics for today. That is, one is heat capacity, and then one is specific heat capacity as well. So yeah, all right, where am I going to? Day, why? Why is this? I went to slide number 24. Wait, what? This is so hard. Okay, I don't know how Abhishek sir does this. Seriously, all right. So welcome to the session once again. So let's focus for another 10, 15 minutes, 20 minutes at the most, and then we'll again come back to the quiz. So, two topics, two very important topics. One is heat capacity, and the other is specific heat capacity. What is heat capacity? If I have to explain in simple terms, heat capacity is nothing but the amount of heat energy required to raise the temperature by 1 degree Celsius of a particular substance. It could be any substance for that matter, aluminium, water, iron, whatever material, whatever metal, non-metal, whatever it is. The amount of heat energy required to increase the temperature of that body by 1 degree Celsius, that is what is heat capacity. So that is how you define it, because here's the thing guys, every object requires different amount of heat energy to raise the temperature. I gave you the example last session also. For example, if I give if I give 1 calories of heat energy to water at certain temperature, like for example, let's say at 14.5 to 15.5, it will increase the temperature by 1 degree Celsius. But then at other temperatures, it might not. But the same 1 calories could increase the temperature of aluminium by about 4 degrees Celsius. So different objects have different amount of heat that they require in order to increase the temperature. That is one thing you have to understand. Not every object is the same. So if I have to talk about, if I have to define what is heat capacity, it is nothing but the heat capacity of the body, for bodies, the amount of heat energy required to raise the temperature by 1 degree Celsius. And hence the formula would be heat capacity is equal to the amount of heat energy supplied in terms of joules divided by the raise in temperature. It can be in terms of Kelvin or in terms of joules as well. But the SI unit will be joules per Kelvin itself. So joules per Kelvin would be the SI unit, and you can also use the unit. Very common units are joules per Kelvin, degree Celsius. We also have calories per degree Celsius as well. So these are all the different units, but ultimately this is the first formula that you have to remember, because once again we will be solving some questions based on this. So this is the first question, this is the first formula. Heat capacity is nothing but the amount of heat energy required to increase the temperature of a body by 1 degree Celsius, right? Is it clear, people? All good? So far so good? Everyone is able to understand? So this is the formula, where C is nothing but the heat energy, C dash, it's written as C dash, which is equal to Q. Q is nothing but the C is nothing but the heat capacity, Q is nothing but heat energy, divided by delta T. Delta T is nothing but the change in temperature. So here it's generally taken as 1 degree Celsius change in temperature is what you take. So whatever is the change in temperature, 14 to 15, 13 to 12, whatever it is, so 12 to 13, whatever it is, that change in temperature is what is represented by delta T. Right? Crystal clear? Awesome! All right. So this is the units, people. Joules per Kelvin, joules per degree Celsius, and it can also be calories per degree Celsius as well, depending on what you choose. But then SI unit would be joules per Kelvin, right? Because the SI unit of the SI unit of heat is nothing but joules. SI unit of temperature is nothing but Kelvin. Woohoo! Done. Alright, so that is the end of the first topic, guys. That is the end of the first topic. Hi, Muskan, welcome. Now, the next topic I'm going to talk about is specific heat capacity. What is the difference? Now, here's the thing, guys. For a very long time, scientists had an idea about heat energy. They knew how it worked. But then they could not, the problem was that, because when you talk about heat energy, you always consider the mass. Yes or no, people? Because we have seen that, for example, if I want to heat up a glass of water, and if I want to heat up a tumbler of water, which of them would require, which of these do you think would take more time? The glass of water or a big tumbler of water? Which of these do you think would require more time? A tumbler or a tumbler? Absolutely, yes. I mean, not the glass of water, but the whole tumbler, right? The whole vessel. Because why? The mass is more. So for a very long time, the problem was that the scientists who were working on this had the clue that, yeah, this is what they're supposed to do. But then they always had this problem that you're considering the mass. So that is when they brought in this concept of specific heat capacity. So what is specific heat capacity? If the mass of an object is kept constant, if the mass of an object is kept constant, let's say that it's 1 gram, right? So 1 gram of water, 1 gram of aluminium, 1 gram of iron, 1 gram of bronze, whatever it is. If I take the mass to be as exactly 1 gram itself, like I'm not changing the mass at all, then the amount of heat energy required to raise the temperature by 1 degree Celsius, that is what is called as specific heat capacity. All right, let me tell this one more time. Listen up carefully, people. if the mass is kept, because when you talk about heat capacity, we did not talk about the mass. We did not consider the mass now. We only talked about the heat energy required, and we also talked about the change in temperature. But here, when you talk about the mass, when you consider the mass as well, if you take the mass as 1 gram and then find out how much heat energy is required to raise the temperature by 1 degree Celsius, that is what is called as specific heat capacity. Did you understand this? Is it clear? Is it clear, or are you still confused? Is it clear, people? All good, all good, all good? Yo, nobody reply. Yeah, Alina, clear? So that is what a specific heat capacity, people. So this is how you define it. Specific heat capacity is of a substance defined as a heat capacity per unit mass. So if I take it as 1 gram or whatever it is, you can take it as 1 kg also, it's totally up to you. So the heat capacity of a substance, the specific heat capacity of a substance is the, wait, what? Okay. Wait, this is too much, da. Wait. 1 second, Wait, let me go to the first diff. Specific heat capacity of a substance is defined as the heat capacity per unit mass, which again the formula is nothing but specific heat capacity is equal to heat capacity of a substance divided by the mass of the body. Now again, what is the formula for heat capacity? We just saw right now. That is nothing but Q by T. That is Q by delta T is the formula. So if you look at the formula, this formula would become like this. That is, here specific heat capacity is nothing but, see, I'll just write it over here. Specific heat capacity is nothing but, this thing is like, specific heat capacity is nothing but C is equal to heat capacity, which is nothing but C dash. I'll take it as C dash itself over here. So C dash is nothing but heat capacity divided by the mass of the body. So if I consider the mass as well, that is what is specific heat capacity. So heat capacity, we know C dash is what? C dash is equal to what? C dash is equal to, we just saw that before, it is nothing but Q by delta T, that is the formula. So if you substitute this value in the first equation, so you'll get it as C is equal to Q by delta T into M. This is the formula. This is how you get C is equal to Q. Alright, I ended up breaking this also now. So yeah, people, that's how you get it. That's how you get C is equal to Q by delta T into M. Right? Clear? Like I told you, it's just that I'm new to this thing. I've never used this before, so I ended up breaking this thing also. So congratulations to me. I have done the impossible, so yeah, they'll remember me forever now. So that is the answer, guys. So that's how you calculated specific heat capacity. The formula is what? It's nothing but C is equal to Q by M into T, delta T. Because again, we'll be solving some problems as well based on this. So that is the answer for this question. All right, yes. That's how you solve it. All right. So if you have to define it another way, you can define it like this as well. Specific heat capacity of a substance. Patience. Oh my god, this is like, wait, what did I do? I'm never taking a session on this one ever again. This is the first and the last time that you're going to see me like this. Never ever again. This is like, alright, anyway, specific heat capacity is what? Of a substance is the amount of heat energy required to raise the temperature of a unit mass of substance through 1 degree Celsius or 1 Kelvin. That is what is your specific heat capacity. So the formula again is C is equal to what? The amount of heat energy required divided by the mass into the raise in temperature. The amount of heat energy is nothing but Q by M into delta T is the formula. So that's how you get it. So again, the amount of heat energy required to raise the temperature of a body by mass m kg by delta T, that is the temperature, change in temperature in Kelvin. That is what is the specific heat capacity. Now, the relationship between heat capacity and specific heat capacity is this. Specific heat capacity or heat capacity is equal to M into specific heat capacity, because we just saw that C dash C is equal to what? C dash by M, that is the formula. So if you rearrange the equation, what will you get? C dash is equal to M into C. So that's the relationship between heat capacity and specific heat capacity. So the only difference is this, people, that in specific heat capacity, we consider the mass, we don't consider the mass, we don't consider the mass. Mass is kept constant as 1 gram itself, but heat capacity is a generalized way of finding out how much heat is required to raise the temperature of a body by 1 degree Celsius, right? Cool down, right? This is insult. All right, next one guys. So this is one thing. Then we have to also do, yeah, the difference between heat capacity and specific heat capacity. Difference between heat capacity and specific heat capacity is nothing but this. So if you talk about heat capacity, people, this is the thing. It is the amount of heat energy required to raise the temperature of a body by 1 degree Celsius. Specific heat capacity is nothing but the amount of heat energy required to raise the temperature of one unit mass of substance by 1 degree Celsius. Again, you're considering the mass as well. That is the, I mean, in the sense, you are keeping the mass constant, so you don't consider the mass at all. But in this case, we are considering only the heat energy required and the temperature. So it depends on both the substance and the mass of the body over here. Here, it does not depend on the mass. That is the difference. Here, guys, remember in specific heat capacity, we do not consider the mass because the mass is exactly going to be 1 gram or 1 kg. It's going to be unit mass. We're not going to take anything else at all. So it does not depend on the mass, but it only depends on the substance. So what type of substance that you have, whether it's water, whether it's whether it's aluminium, whatever it is, whatever does that matter, that is what matters. And the formula is C is equal to Q by delta T. Here is C is equal to Q by M into delta T. That is the only addition to that. And the unit is joules per Kelvin. Here it is joules per kg Kelvin. So that's how it is, because here again the unit is M is nothing, okay, mass is nothing but kg, and delta T is nothing but Kelvin. So it'll be joules per kg Kelvin. That's all, people. That is all. I mean, yeah, this is one more example of what are the specific heat capacity of different materials. Again, few of them, again, like I told you, every material is different in its own way. So if I have 1 gram, again, the question is this, so not 1 gram, 1 kg of any of these substances, 1 kg of lead, 1 kg of mercury, 1 kg of brass, 1 kg of zinc, copper, whatever it is, how much heat energy is required to raise the temperature by 1 degree Celsius? That is what this tells you. So for 1 kg of lead, I require about 130 joules per kg Kelvin. That would be the specific heat capacity. That is how much amount of heat energy that I require in order to raise the temperature. Same goes with mercury. Same goes for mercury. It's 139. So you see this for every element, it's different. So brass, it's 380, zinc, it's 391, copper 399, and if you go down, aluminum is 882, ice is 2000. So water in general has very high specific heat capacity. It takes a lot of heat energy to raise the temperature. One of the best examples I can give you is this. So all you have to do is this, guys. Take a metal chair, keep it under the sun for the whole day. Take a bucket of water and keep it under the sun the whole day. If you keep it under the sun, both of them, if you keep it under the sun the whole day, you see that the chair would be much more hotter in comparison to the water. The chair would be, so it's not that you're giving any sort of partiality, it's just that the metal that is there will absorb, because it has high specific heat capacity, it'll absorb more amount of heat, whereas water on the other hand, it requires a lot of heat in order to raise the temperature, and hence it has very high specific heat capacity. Now what is the importance, what is the significance of that, people? If you have low specific heat capacity, that means that you can easily increase the temperature. You don't have to give so much amount of heat energy. You can easily increase the temperature. That is one advantage. The second advantage is that if there is low heat capacity, that is, it will be a good conductor as well. Like in the case of copper, like in the case of iron, they are good conductors of heat. Why? Because they have low specific heat capacity. Whereas water, on the other hand, has very high specific heat capacity. That is why water is used in radiators to cool down few things and all. Like even in the case of nuclear power plants, also we use water. The coolant, is water itself, because it requires a lot of heat energy in order to increase the temperature. That's why. And finally, people, if you have high specific heat capacity, like in the case of water, which has about 4,200 joules Kelvin, kg per Kelvin, for that, it has very high heat energy. That means that you require so much amount of heat energy in order to raise the temperature by 1 degree Celsius. And yes, people, that is pretty much it for today. We'll get back into the quizzes now. But yes, people, if you want to have such amazing sessions. I know that today's session was somewhat more of a joke than an amazing session, but still, if you all have a lot of fun like this and want to learn with some amazing teachers that you have around Vedantu, you can always click on the link that is given in the description as well as in the pinned comment section below, people. So that link will take you to the channel of Vedantu, the website of Vedantu, where you have unlimited live sessions just like this one, and you'll have a lot of fun, and also have quizzes just like what we did in the start and what we're going to do. And apart from this, people, because of these quizzes, you have this opportunity to compete with the rest of the world and see how good you are at that particular subject. And apart from this, people, you can download all the premium content and as well as take part in the interactive replay session. So if in case you miss out a session, you can still take part in those sessions and still take the quizzes and check out the leaderboards as well. With that, like I told you, you can download all the premium content and download every single notes, watch every single replay of every single session as well. And apart from that, you can also get your doubts cleared inside the session itself, because we don't have just one teacher inside the class. With the master teacher, you will also have the class teacher as well. So you'll have the master teacher and the class teacher in order to clear your doubts. So whatever doubts you have will be cleared inside the session itself. There's no need for you to go out anywhere at all. All the doubts will be cleared right there and then. And finally, we will, with all of these 5,000 plus micro courses and crash courses all for free. Again, the link is given in the description as well as in the comment section. The coupon code is AME Pro. This is my coupon code AME Pro to avail the discount. So what is the discount and what does it cost? Let me just tell you that as well. So for the 1 month program, the base price is 2,699. But if you use a coupon code AME Pro, you get a discount of 500 rupees and the price drops down to 2,159. The same goes with the 5 month program, which is going to go until June of 21st. So for that, the base price of that will be, so if you calculate, it's around 2,700 into 5 months. It's a lot of money. So in order to give you guys the best of the best abilities, in order to spread the word, we have reduced the price down to 7,200 rupees. That is if you use the coupon code AME Pro. And if in that 1 month duration, if you just think about it for a second, you would have attended roughly about 200 sessions. That means that you'd be paying about 11 rupees per session. And if you go for the June wala program till the start of your exams, for that you would have attended about 1,000 sessions. That is in the next 5 months. That means that the price drops down to 7 rupees to Paise. Yeah, that's it, right? So again, the link is given in the description as well as in the the pinned comment section. So check it out as well. Come on in, please do come on in. So yes, people, we have a celebrity among us. Huh? Yeah, it's going on like. Look at that. Look at that. Look who's here. Look who's here.
What's up, people? What's up? Hey, ask me here.
A lot of people are here. A lot of people from your sessions are here. So yeah.
What's up, people?
Yes. Look at that, Janu sir. So much love. So much love.
You're using my lesser than your least packaging, huh?
I don't have a choice though. Yeah, you're forcing me to use it.
Right. I'm pretty sure they're like, sir, आप 9 दिन हिंदी चल में नहीं है. नहीं बेटा, मैं थोड़ा बीमार था और हमारे घर का थोड़ा इधर शिफ्टिंग हो रही थी, इसलिए नहीं हुआ. कॉल उठाओ. अरे आसिफ की थोड़ी सी मीटिंग चल रही है.
Abhishek sir got a new house and all, people. He did not even treat us till now.
Before me,
Kanjus.
got a new house.
Kanjus. Like it's written on his head, you can see that.
Kanjus, no?
Yeah, Kanjus is written on his head.
On your head also, a lot of things are written.
Yeah, that is just greatness. You can't. Anyways.
Bale. So enjoy. Tata.
Enjoy. Yeah. This is like the worst thing that has ever happened. Alright. Anyways, so people, that is it. So yeah, party. I know, right? I'm expecting a party, but yeah, he's like, he'll give. I know, Janu sir. Yeah. Alright then. Okay, people. So yeah, let's go on to the Mentimeter now. Quickly finish off these questions as well, people. Let's get back to this. Yep. This is your final Mentimeter. Let's quickly finish this off. So we have, again, the code remains the same. 7768346 is the code. So quickly join people. Come on. How much time does it take to reach Vedantu office from my house? I stay like 20 kilometers away. Abhishek sir stays about 6 kilometers from my place. So that's about 14 kilometers for him and about 20 kilometers for me. That's it. Very close. Very, very close. All we need is an airlift. I wish, Vedantu had a helipad. So you could have done that. Alright, people, quickly join the Mentimeter. I'm going to start the quiz now. Quickly. All of those who are not in yet, quickly join the Mentimeter. Alright, the fourth question. No? Quickly. Done. Awesome. I'm going to start the quiz, people, in 5, 4, 3, 2, 1. Let's go. The code remains the same, 7768346. If you have not joined yet, quickly join. The question is this. The SI unit of specific heat capacity is what? What is the SI unit of specific heat capacity? Options. Joules per kg, joules per Kelvin, joules per kg per Kelvin, kilocalorie per kg per degree Celsius. Alright. So what is the SI unit? Specific heat capacity. All right. Okay, guys, take this as kg per Kelvin. All right, kg by Kelvin. Good. You guys did the same thing. Awesome, guys. Exactly correct. The right answer is it's joules per kg Kelvin. All right, kg Kelvin. So that's how it is. Here they've, just to represent it, they've done it this way. So yes, absolutely correct, guys. 21. Amazing, people. Amazing. So here, that's 88% of the class. Beautiful, guys. Oh, I didn't know that you could do that. That's cool. You can see the percentage now. All right, I'm figuring out a lot of things today. Today is like a very enlightenment day. All right, Mohit on the top, followed by Joseph, followed by Bhargavi. Then it's like you have no other name, no? Like there are billion names out there. There are 7.7 billion people. So many names, and you have to go with this one. Then it's KJ, hello, Dai, Kwahish, Sharma, and Tushar as well. Congratulations, guys. Well done. Moving on to the next question. Here's another one. People take a look at this question. Fifth question. I believe it's going to be a problem, so make sure that you have your pens and papers with you and try to solve this. The question is this. Calculate the heat capacity of a copper vessel of mass 150 grams if the specific heat capacity of copper is 410 joules per kg Kelvin. All right. So that is the question. Calculate the heat capacity of a copper vessel of mass 150 grams of the kg if the specific heat capacity of copper is 410 joules per kg Kelvin. Let's go, guys. Come on. Let's do it. Sure, Devapita, why not? Devapita ji, why not? Why not? I can't see any of your chats. I'm like, I'm just going blind over here because like I told you, this is the first time I'm taking sessions over here, guys. So it's like, it's hard. It's very hard. And when I look at myself, I'm like, what? When did I become a mini elephant? That's what I'm thinking. Hello, Loiji, what's up? How are you doing? Hi, Hemraj. Sir, after exams, I'll come. Yeah, Ashvi. Let's see. Yeah. Sure. Thank you, Ayushi. Thanks a lot, buddy. Welcome to the session. Yo. Done. Hi, Rachel. What's up? Okay. Awesome, people. 24. My God, you guys are rocking it today. You guys are rocking it today. What happened? Javan Prasha. Awesome. So how do you solve this question, guys? Let's quickly go back to that. I mean, how to solve this question as well. Let me just show it to you, people. So once again, this is the question, I believe, right? Yes, this is the question. So how do you solve this? It's quite simple. Again, so they've given you the mass. 1 second. Day. Every time. Touch screen. No. Touch screen is spoiled. Where am I going? 1 second. Guys, I'm really sorry. I know that I look like a fool right now. It's only because I've never figured this thing out yet. Alright, so mass is given as 150 grams. First of all, guys, convert this to kg because here you see this, the unit is given in terms of kg. So convert that to kg first. So divided by 1000, that's 0.150 kg is what even. Why is it like this? Okay, 1 second, guys. Yeah, so it's 0.150 kg is what you're going to get. Now use the formula. We know that specific heat capacity is nothing but, okay, I will just take it as heat capacity itself. Specific heat capacity is equal to heat capacity divided by the mass. So, they've given you the specific heat capacity. You're supposed to find out the heat capacity. So, specific heat capacity is equal to C into M. C is given as 410 into 0.150. So multiply this. What is it that you're going to get? 410 into 0.150, sorry. How much is it that you're going to get? Come on, people, quickly. Thank you, Bhargavi. So what is the answer? 62.5, is it? I'm believing you, Dai. Hi, Saksham. What's up? Alright, yeah, people, I'm believing our boy and I'm going ahead. So yeah, people, that would be the answer. What is all this, duh? Okay, so yeah, guys, that is the answer for this question. I believe that is the right answer. Yeah, the answer is 61.5. Well done. Awesome. Next question, people. Next question. Let's get back to the Menti now. How? Exit. Menti. Let's go. Next question, people. Here's another one for you, people. So before that, here's your leaderboard, by the way. I forgot to show you the leaderboard. So this is your leaderboard. We have Mohit still on top. Mohit is like full on rocking today. Where is Mohit? Where is our boy? Followed by Joseph, followed by Bhargavi. No, Joseph goes to the top this time. Sorry, Mohit. Followed by Bhargavi. Then it's Mohit, hello, Kwahej, Zai, Adai, Tushar, J, and Ayushi. Like there's two Tushars in the class, no? Both of them have the same last name and the first name also. It looks very suspicious. Tusharji, from two phones you're answering the question or what? Alright, here's your sixth question, guys. The next, this is also another problem itself. This is your sixth question. Go ahead and try to answer this one as well. The question is, a piece of iron of mass 2 kg has a heat capacity of 966 joules per Kelvin. Find the heat energy required to warm it by 15 degrees Celsius and its specific heat capacity as well. First of all, you're supposed to find out what is the heat energy. Secondly, find out the specific heat capacity. Options are 14,990 joules and 483 joules kg per Kelvin. 16,520 joules and 400 joules kg per Kelvin. Then 2,490 joules and 40 joules per Kelvin, kg Kelvin, and then 144 joules and 4,830 joules per kg Kelvin. Let's go! You're supposed to find out what is the heat energy and also find out the specific heat capacity. Let's go, guys. Come on. Yeah. Ashmi ji, why? What did we do? What did we do? Hey, this is what? It's all tangled up. It's like a, all right, Manish is full cont. Okay, there's Tushar S and there's Tushar Ador also. All the best, Gauri, all the best, duel. Why are you scared? It's okay. It was supposed to happen a little sooner. At least you got so much time to prepare, no? So don't worry about it. You'll do great. Don't worry. All the best. Enjoy yourself, but I'm sure you'll do amazing. Do well, all right? Yo, guys, let's go. Yeah, we are, Ayushi, because we've been friends for almost 8 years now. So, yeah. Yo, is it, Ashiji? I know. Thanks a lot. Alright, so people, that is the answer. Awesome. 17 of you guys got the right answer. Not bad. A couple of you guys might have made some calculation mistakes, but that's not a bad percentage at all, people. So let me just quickly show you this one as well, how to solve this. So here it is, people. This is the question. Okay, where's the question? No? This is the question. No? How? This is the question, right? No. Did this thing, it went to the last slide. Why you do this? Why you insult me like this? Alright, so people, how do you solve this question is quite simple again. So first of all, they've given you the mass, you're supposed to find out what is the heat energy. Now remember the formula of heat capacity C dash is equal to what? Heat energy required divided by the change in temperature. That is the formula. They have given you the heat capacity. You're supposed to find out what is the heat energy. You're supposed to find out what is Q over here, and the temperature is nothing but 15 degrees Celsius. So leave it for 15 itself. So you have what? The formula would become Q is equal to C dash into delta T. So C dash is equal to what? 966 into delta T is nothing but 15. So what is it, people? I think you'll get it as 14,440 something, no? How much will you get? 14,000, how much? 14,400 what? How much is it? 14,000? Calculator, 966 into 15 is how much? Quickly people. How much is it? Yeah. Answer is D. Connects. Yeah, Manasi. What is the answer, people? Quickly now. 490 is it? Okay, alright. So that is the answer, people. That is the answer. And it'll be joules, in terms of joules, because it's heat energy. So that is the answer for the first question. Now for the second question, you're supposed to find out what is the specific heat capacity. Formula is quite simple. C is equal to what? C is equal to Q by M into delta T is the formula. So Q, you have already found it as 14,490 divided by mass is given as 2 kg into the temperature is again 15 degrees Celsius. The change in temperature is 15 itself. So calculate it, you will get the answer. That's all, guys. That's all right. So that is the answer for this question as well. So that would be the end of the next question. So this is how you do it. So you will get the answer as this one. So they have directly, so here they've taken it as directly, they've taken it as heat capacity. What I did was I used the formula. That's all. I used the formula. Here they've taken it as heat capacity directly. 966 they've substituted. I took it as Q by M into delta T. That's all right. That is the only difference. That is the answer for the next question as well. Moving on to the lowest question. That's all. Lowest question. That's it. So here is your leaderboard, by the way, guys. At the end of that question, we have Joseph Tennis on the top. Okay, yeah, still on the top only. Followed by Bhargavi, followed by football, followed by Mohit. Let me just see now. What is this? That's all. Montana, followed by Hello, Kwahish, Tushar J, Mohit, Daya, and Sharma as well. Congratulations, congratulations. Well done. With that said, people, last question. Moving on to the last question for the day. Finish this also with a bang. This is the last 7th question. Again, it's going to be a problem itself, so read it carefully and then answer. The question is as follows. What is the question? Find the amount of heat energy required to raise the temperature of 100 grams of copper from 20 degrees Celsius to 70 degrees Celsius. Specific heat capacity of copper is 390 joules kg Kelvin. Let's go, let's go, let's go, let's go. Arey Ashmi ji, sorry, we've been a little busy, that's all. Sure, Devpita, why not? Once you come down to Bangalore, just give us a call or come down to Vedantu office. You can meet all your teachers. It'll be amazing. Right now, though, we have all teachers over here, by the way. We have, I think we have Harsh sir is here. We have Gopal sir. We have Ankana ma'am is also here. So pretty much all, even Anubha ma'am is here. So pretty much everyone is here. Who's my crush? I don't crush, I get crushed. So my pre-boards are coming on 10 days. I have less time. Don't worry, Gauriji. Don't worry. It's okay. Don't worry, because tension is not going to get you anything. I know that it's a common feeling of getting tensed, but it's not going to bring you anything good. So relax yourself. Tell yourself that you've studied so much, because I'm pretty sure that it's not that you're scared because you're prepared, but you're scared about what kind of questions are going to come in the exam. So don't worry about whatever the kind of questions you might come in the exam. Don't worry about that. You give your best shot, because anyways it's your pre-boards, not your boards. And even if you do bad, you will get an idea of how to do it better in your boards. So don't worry too much about it. Don't take so much tension. Do your best. That's all I can say, right? Good evening, Shreya ji. What's up? It's alright. So start a music band. Abhishek sir sings or what? I've never heard Abhishek sir sing. Okay, because I generally tell him to sing when I want to scare crows away. Hi Tushar, what's up? Don't tell this to Abhishek sir. Don't tell this to Abhishek sir. This is a secret between us. Hi Arita, what's up? Amazing people, amazing. 21 of you guys got the right answer. Spectacular, guys, spectacular. Proud of you guys. So how do you solve this question? Once again, it's quite simple. So yes, let me just go back to this question. This is the last question, people. Let's quickly do this as well. So calculate the amount of heat energy required to raise the temperature of 100 grams of copper by, first of all, it's given us 100 grams, so change that to kg. Kg. So change so that'll be what, 0.1 kg is what you're going to get. So mass you're going to 0.1 kg. Then now, here they've told you to raise the temperature from 20 degrees Celsius to 70 degrees Celsius. That means that they're asking you to find out the change in temperature. Change in temperature is what? 70 minus 20, which is nothing but 50 degrees Celsius. So you found out what is the change in temperature. Now to find, so they've already given the specific capacity as well, which is nothing but 390 joules per kg Kelvin is what you have. Use the formula, directly put down on the equation, put on the formula. C is equal to what? C is equal to Q by M delta T is the formula. So we have delta T, we have M. You have to find out the heat energy. So amount of heat energy. Heat energy is equal to what? C M delta T would be the formula. C is not, it is nothing but 390. Mass is nothing but 0.1 and delta T is nothing but 50. So multiply this, you'll get the answer. 390 into 0.1 into 50 is what you're going to get. Yeah, people, that is exactly correct there. Exactly correct. So this is the formula, people. This is how you do it. So calculate this, you will get the right answer. 390 into 0.1 into 50. Whatever is the answer that you're going to get, that would be the answer for this question as well. And by that, the final leaderboard for the day. That's it, people. That's it. This is the final leaderboard for today. So the right answer is 9,001. So this is your final leaderboard as well. The winner is all the way from North Carolina. We have Joseph Dennis. Congratulations, buddy. Congratulations. Well done. Followed by Bhargavi, followed by Montana, followed by Kwahish, followed by Dai, followed by Mohit, Tushar, and Sharma, and KG as well. Joseph G, congratulations. Well done. That is the final leaderboard as well. Congratulations, buddy. I'll be taking a photo of this and I'll be putting it up in the Telegram group as well, so don't worry about it. So that's it for today, people. Let me know if you have any doubts. Anything that you want to ask me, do let me know that as well. So yeah, that is it for today. Thanks a lot for joining. Thanks a lot for waiting up for me, people. Because like I told you, I was trying to figure this out, and you understand how big of a noob I am when it comes to this one. So this is probably going to be the last time that you're going to see me in front of this one. But yes, nonetheless, it was an interesting experience. So this is the answer. This is your homework, by the way, guys. What is the specific heat capacity of water? That is the question. Let me know what is the answer in the comment section. This is your homework as well. And by that, we have completed the topic. Do not forget to subscribe. Do not forget to hit the like button. And that's it, people. Next session would be on Tuesday. I'll be coming live on Tuesday again. But Balai people. Sir, do you know how to dance or cook? Look at me right now. Look at me. I look like a mini elephant. Me dancing. Cooking though, yeah. I know I don't know how to cook, but I can eat. I can seriously eat. Like you give me anything, I'll eat. That's like a special talent that I have. Like I can challenge anyone for that. I'm like next level. Next level about that. Yeah, sure, Joseph. Don't worry. Congratulations, buddy. Well done. Now, so that's it, people. That is it from my side. Yeah. That's it. Yeah, in every session, Dimpy. Yeah, but I have to come to the office every day. That's like, I told you, it's like 20 kilometers and it's not safe also. I'm seriously scared. Like everywhere I walk around, I literally I didn't wash my hands in sanitizer. I bathed my hands in sanitizer. My hands were dripping with sanitizer. Like everywhere I go, anytime I touch something, my hands are dripping with sanitizer. I sanitized my hands so many times today. It's become so white. Alright guys, so that's it. Yeah, I'll check it out, don't worry. So yeah guys, that's all for today. Thank you for joining. I'll catch you guys in the next one. Take care of yourself. Thanks a lot for waiting up. I really appreciate it, because I know that you guys had a lot of things to do, but then thank you for waiting up and thank you for being so patient. I'll catch you guys in the next one. Take care of yourself and all the best for your pre-boards, people. All the best for shot. All the best. Don't worry, you guys will do great. I trust you, people. I know you can. You guys look at that. Look at this muscles and all. No doubt. If I can do it, you can also do it. Got no relationship, but still, pre-boards, all the best. Do well, people. That's all. Bye-bye, guys. Take care of yourselves. Stay safe. I'll catch you guys in the next one. When will the whole syllabus be complete, Alina? By the end of this month, it'll be done. Don't worry, all right? Anyways, your exams are starting in the month of, I believe, June, right? May, June, that is when it is set to start. So April, May, June, that is when it is set to start. Most probably June. So don't worry, by then though we would have completed at least 2 rounds of revision, all right? So yeah. Alright guys, bye. Thanks a lot for joining the session, guys. Bye. See you all in the next one. Take care. Bye. See you all. Yeah. No. That was